Hello. So last night you guys watched a video that introduced the first 3 pages of this packet. And today what you're going to do is you're going to try out some examples on your own. So what I'd like you to do is I'd like you on this first page to just review the rules at top. And then I'd like you to try out examples 1 and 3 on your own. And, pause the video and try them out. And then when you're done, hit play and see how you did. All right, so let's take a look at number 1. Now, number 1, I'm just going to, go through it step by step. All right, so the first thing I'm going to do is, with these two terms on top, x to the 10th times x to the 6th. We know when we're multiplying two terms with the same base, we add the exponent. So that's going to give me x to the 16th. Okay, now let's look at the denominator. Here, we have a power being raised to another power. And we know when we have a power being raised to another power, we multiply the exponents. So since 4 times 2 is 8, we get x to the 8th. All right, and then finally, here we're dividing two terms with the same base. So when we're dividing two terms with the same base, we subtract the exponents. So 16 minus 8 is 8, so it gives us x to the 8th. All right, so this one actually used all 3 of the rules at the top here. All right, let's take a look at number 3. All right, number 3, we have a couple things going on here. So I'm going to just take it one step at a time. All right, so let's look at this first fraction. This first fraction is being raised to the 3rd power. And remember, since we have parentheses here, you have to go through and you have to raise every term within the parentheses to the 3rd power. All right, so let's do it. So let me do this. We have 2 fractions going on. We're just working with the first one. So 2 to the 3rd power, right? 2 to the 3rd is 2 times 2 times 2, which is 8. Okay, then we have to raise this a to the 4th to the 3rd power. Remember, if you have a power raised to another power, we multiply those exponents, right? So since 4 times 3 is 12, it gives us a to the 12th power. Okay, and then in the denominator, we just have to raise the 4 as well as the b to the 3rd power. So 4 to the 3rd power, 4 times 4 times 4 is 64. And then b, when you raise that to the 3rd power, is just b to the 3rd. Okay, now if we look at our second fraction here, I'm just going to take this numerator and just bring it right over for right now. So 8a b to the 4th. Okay, what I'm really doing is I'm first getting rid of all the parentheses I see. So on the bottom here, I have a parenthesis. So I have to individually raise each term to the 4th power. So the first thing I'm going to do is negative 2 to the 4th power. Okay, if you think about that off to the side, negative 2 to the 4th, all that means is negative 2 times negative 2 times negative 2 times negative 2. I mean, if you wanted to, you could, I guess, plug that in your calculator. It would give you positive 16. Okay, whenever we have an even number of negatives, it's always going to be positive. Okay, and then I need to take the a squared and raise it to the 4th. So since we have a power raised to another power, 2 times 4 is 8, we get a to the 8th power. And then here, we're going to take this b and raise it to the 4th power. So that'll just be b to the 4th. Okay, so now from here, I mean, there's a couple different ways you can go about this. I'm going to look and I'm going to see what can cancel off. You can cancel off anything in either one of these 2 numerators with anything in either one of these 2 denominators. So for example, I'm going to look at the numbers first. Here we have an 8. And then times another 8. Isn't 8 times 8 64? Okay, so what I'm going to do is I'm just going to cross off the 64 on top, which is the 8 times 8, with the 64 on bottom. Okay, so those cancel off. All right, so it looks like in the denominator, we're left with 16 as our number. And in the numerator, I guess we have a 1, right? All right, now let's look at our terms with the 8's. So it looks like here, on the top, we have a to the 12th, an a to the 1st, and an a to the 8th. Now, let's think about this. If we have, I'm going to do this. If we have 8 a's, right, being multiplied together, can't these 8 a's cancel off with 8 of these a's, right? So if I cancel off this a to the 8th on the bottom, I'm getting rid of 8 of these a's. So since 12 minus 8 is 4, it's only leaving me with 4 a's in this spot. So I'm going to cross this off and make this say a to the 4th. Okay, and then that's pretty much it with the a's because we don't have any more a's on the bottom. We just have a's on the top here and here. Now let's look at the b's. We have a b in the denominator here and a b in the denominator here, and we have a b in the numerator here. Well, look at this. These b's both say b to the fourth. So wouldn't the b to the fourth on the top cancel off with the b to the fourth on the bottom? So now we're going to carefully go through and we're going to see what we're left with. Okay, you don't want to miss anything, so be super careful. And when you do, you're going to put it all into one fraction. Okay, so on the top, we have an a to the fourth times an a to the first, which we know when we multiply two terms with the same base, we add the exponent. So that'll be a to the fifth. Okay, now on the bottom, we have a b to the third and a 16, and it looks like that's it. So I'm going to rearrange it as 16b cubed. And that would be our final answer. Okay, nothing else. Simplifies. Okay, so here we're talking about in the next page 0 exponents. And I know the Ed puzzle went over numbers 4 and 5 with you. What I'd like you to do is hit pause and try out numbers 6 through 9 on your own. Okay, so number 6. Well, here you're taking 3m and raising it to the 0 power. Since we're raising the whole entire thing to the 0 power, this is just equal to 1, right? Anything to the 0 is equal to 1. I mean, if you want to think about it as distributing that 0 power on each term within the parenthesis, you can think about it like this. You would have 3 to the 0 and m to the 0. And since 3 to the 0 is 1 and m to the 0 is 1, 1 times 1 gives you 1. Okay, but I like to just think about it as a whole. If the whole thing is being raised to the 0 power, then the answer would be 1. Okay, number 7 was a little tricky because it's really just the 3 that's being raised to the 0 power. This negative sign isn't. If the negative 3 was being raised to the 0 power, it would have been written like this, negative 3 to the 0. And then that would be equal to positive 1, right? Because anything raised to the 0 power is 1. But here, it's just the 3 that's being raised to the 0 power, and this negative is in front of it. So this is really equal to negative 1, okay? Because the negative sign comes over, and 3 to the 0 equals 1. So there we go. All right, in number 8, the m is the only thing being raised to the 0 power. The negative 3 isn't. So here, this is like negative 3 times 1, right? We can bring the negative 3 down. And since m to the 0 is equal to 1, it's like negative 3 times 1. Oop, pen isn't working. So that's equal to negative 3. Okay, and then finally number 9. I mean, this whole entire thing is being raised to the 0 power, so it's equal to 1. And that's it. I mean, again, if you want to think about it as 3 to the 0 over m to the 0, then you'll have 1 over 1, but either way, it simplifies to 1. All right, so now let's look at on the bottom of the page, negative exponents. So I know on the Ed puzzle last night, you went over numbers 10, 11, and I think down there, number 15. So what I'd like you to do is on this page, I'd like you to try out the ones that we didn't do. So 12 through 14, and then hit play and check your work. Okay, so number 12, let me just move this up a little. Might as well get them all on the screen. So number 12, the first thing I'm going to do is I'm going to make that into a fraction by putting it over 1. Because we know in order to make an exponent positive, we move the term that has the negative exponent on it to the opposite side of the fraction bar. So since this 3 to the negative 2 is in the numerator, when we take that and move it down to the denominator, it becomes positive. So we get 3 to the positive 2 when we move it to the other side of the fraction bar. And then that just leaves us, with a 1 on top, right? If we moved everything out, we have to put a 1 as a placeholder. And I'm going to take this a step further. Since 3 squared is 9, this is going to be equal to 1 over 9. Okay, now let's take a look at number 13. In number 13, the x is being raised to the negative 3rd power, but the 4 isn't. Okay, so when I make this into a fraction, this is really 4 to the positive 1st power, right? Remember, if it has an exponent, a positive exponent, you want to leave it where it is. So I'm going to leave that 4 right on top. The 4 to the positive 1st stays on the top. And then here, x is being raised to the negative power. So if I want to make that exponent positive, I move it to the other side of the fraction bar. So when I move it down to the denominator, it becomes x to the positive 3rd. All right, and that's our answer. All right, now in number 14, the 4 and the x are being raised to the negative 3rd power. So what I'm going to do is, I mean, you could do this one of two ways. You can distribute the -3 onto both terms if you want, but I'm just going to take this whole thing, and since the whole thing is being raised to the -3rd power, I'm going to move that whole thing to the denominator, and when I do, I'm going to raise it to the +3rd power, okay, because I moved it to the other side of the fraction bar. And then because we're not left with anything on top, we want to put 1 as our placeholder. All right, so that leaves us with 1 over. Now I'm going to distribute this cube on each of the two terms. So 4 to the 3rd power, right? 4 cubed would be 64. And then we also have to raise that x to the 3rd power, so that'll be x to the 3rd, or x cubed, however you want to say it. Oop, that's supposed to be an x. Sorry, sometimes it's hard to write with this pen. All right, and that is our answer. All right, so then on page 3, this is the last page we're going to cover today. I'd like you to try out 16, 17, and 19 on your own, because I know the Ed Puzzle did number 18. All right, so number 16. I mean, there's two different ways you could start this. Actually, on my answer key, what I did was I took this -1/2 power and I distributed it to the numerator and I distributed it to the denominator. But you know, I'm looking at this. I think what I might want to do instead is, instead of having a fraction within the parentheses, why don't I just, we know when we're dividing two terms with the same base, we subtract the exponent. So I'm going to do that first, okay? I'm going to subtract those exponents, and then I'll be left with just one term inside the parentheses. Okay, so I'm going to do this off to the side. So if I want to do 2 minus 1/3, well, 2 is the same thing as 2 over 1, and I want to find a common denominator. So my common denominator would be 3. So if I multiply the top and bottom of the first fraction by 3, then here I'll have the same denominators, right? Here, 3 times 1 is 3, and this denominator already is a 3. All right, so this leaves me with 6 over 3 minus 1 over 3. So 6 over 3 minus 1 over 3. All right, and then if we combine those, 6 minus 1 is 5, and we keep the common denominator, so 5/3. Okay, so I'm going to rewrite this as m to the 5/3 power. Okay, so now we have a power raised to another power. So we know when that happens, we multiply our exponents. All right, I'm going to work down here. So it's going to leave me with m to the, well, a positive times a negative is negative. And then I'm just going to multiply my numerators and multiply the denominators. So 5 times 1 is 5. And then 3 times 2 is 6. And then I want to get rid of the negative exponent. So if I put this over 1, okay, all I have to do is take the term that has the negative exponent on it and move it to the other side of the fraction bar. So instead of having it up here in the numerator, let's move it down here to the denominator. So it'll become m to the positive 5/6 when we move it to the denominator. And then you want to put that placeholder of 1 on top. Okay, so this is equal to 1 over m to the 5/6 power. All right, number 17. I mean, this doesn't have parentheses anywhere, so I'm going to say, you know, in order to start this one, I'm going to first move any term that has a negative exponent. Okay, let's get rid of our negative exponents. All right, so if we look here, this is 15 to the positive first power and 25 to the positive first power. Our numbers are going to stay put. They're going to stay exactly where they are because they have positive exponents on them. Okay, now let's look at our x's. This x says x to the -2. Since this has a negative exponent, we're going to move it down to the denominator, and when we do, it becomes x to the positive 2. All right, this is already positive, right? X to the positive 3rd power. If it has a positive exponent, we're going to keep it where it is. All right, then let's look at our y's. In the numerator, it's y to the positive 3rd power. So since that exponent is positive, we're going to keep it on top where it is. And then here, y to the -4th, since this has a negative exponent, if we move it up to the numerator, the exponent becomes positive. Okay, so I mean, I like to do it one thing at a time. Like I first worked with the numbers, then the x's, then the y's. Okay, that way you don't forget anything. All right, so now let's simplify. 15 over 25. Well, both of those numbers are divisible by 5. So 15 divided by 5 is 3, and 25 divided by 5 is 5. So 15 over 25 would simplify to 3/5. So put a 3 on top and a 5 on bottom. Okay, now here in the numerator, we have y to the third times y to the fourth. So here, we know we have to add our exponents. It's going to give us y to the seventh. And actually, the same thing with the x's in the denominator. If we want to multiply x squared times x cubed, we just add the exponents. So that'll give us x to the fifth. Okay, and then finally, number 19. Let me just get down there. All right, this one looks like it kind of has a lot going on, but we can handle it. All right, so the first thing I want to do is when I have parentheses there, I want to get rid of those parentheses. So I'm going to take that exponent that's on the outside of the parentheses and distribute it in. So my numerator, I'm going to leave alone for right now because I don't have any parentheses that I'm working with. And in the denominator, I guess I'll leave that 4 alone. Now, we want to take each of these and raise it to the second power. So we have -3 to the second power. I'm going to put that in parentheses. The square on the outside. Okay, then we have a being raised to the second power. And then we have b to the -5th being raised to the second power. So remember, if we have a power raised to another power, we multiply those. So that'll be b to the -10th. Okay, now I think what I'm going to do next, I'm just going to move anything that has a negative exponent. Okay, so let me move down here, I guess. All right, let me start with my numbers. This 6 has a positive exponent. I'm going to leave it where it is. This 4 has a positive exponent. I'm going to leave it where it is. And this 3 to the -2nd has a positive exponent, so I'm going to leave it where it is. But let's think about it. I'm sorry, -3 to the positive second power. What is -3 squared? Well, -3 times -3 is +9. So I'm just going to make this a 9. Okay, now I'm going to go to my a's. Okay, so I have a to the -8th in the numerator. Since we have a negative exponent, I want to move it down to the denominator, and when I do, it'll make it a to the +8th. Okay, we also have another a down here, a to the 2nd, and that's already has a positive exponent, so let's leave it down there. All right, now let's go to our b's. In the numerator, we have b to the -7th, so if we want to make that exponent positive, we move it down to the denominator. And we have b to the -10th. If we want to make that exponent positive, we move it up to the numerator. All right, so we have the b to the 10th up here. Now at this point, we just want to kind of, simplify this as much as possible. All right, so I'm going to start with my numbers. So on the top, we have a 6, and on the bottom, we have 4 times 9. Now, 4 times 9 is technically just 36, right? So if we think about this, 6 over 36. Doesn't that simplify to 1/6? Okay, so in our final answer, we're going to have a 1 over 6. And we might not need to put that 1 there. If there's other things that go on the top, we can, ditch that 1 later. Okay, now I'm going to go to my a's. We have, in the denominator, a to the 8th times a squared. So we know we have to add these exponents. So that'll give us a to the 10th, and that stays in the denominator. And then let's look at our b's. We have b to the 10th in the numerator and b to the 7th in the denominator. Since we have more in the numerator than in the denominator, you can think about it one of two ways. You could either say these 7 b's will cancel off with 7 of these b's on top. So it's only going to leave me with 3 b's on top, which we could write as b cubed. Or the other way you can look at it is when we're dividing two terms with the same base, don't we subtract the exponents? So 10 minus 7 is 3. And we put those 3 b's on top because that's where the bigger exponent was. So it looks like we didn't really have to write this one. If you want to rewrite this as b cubed over 6a to the 10th, that is the answer. Or if you wanted to leave it with the 1, that's fine as well.